So first, sir, I will give a brief intro,
जी.
and after that, I will just request you to give some insight about RC, and then you can start, sir.
ओके. ठीक है मैम.
Right? I think in 1 minute we will start the session.
ओके.
Yeah. So before we start, I request our audience to confirm that whether we are audible or not. Kindly confirm that. Yeah, I guess we are audible. So first of all, I welcome our guest and good evening everyone. And we are all here today to celebrate World Space Week. So before we begin World Space Week, I would like to share a brief about our company profile. So basically, our company has started in 2017 with an YouTube channel, and in the YouTube channel we have only portrayed about this aerospace for the content for aerospace enthusiast. And today we have registered under MSME, and currently last year we got our company into this one of the first private research and innovation hub, for first private innovation hub, which was also published in Gujarat Journal and other news article. So we are very happy to accelerate this journey, and hoping to look forward. And as we are all here today to celebrate World Space Week, let me give a brief about this, what is and why we are celebrating World Space Week. As all of you know, in October 4, Sputnik 1, the first satellite, has been launched, and how powerful it was across the globe. And space treaty has been signed in October 10th. So in this period, 4th October to 10th October, the lot of other space activity has also been performed. In order to make this history or to accelerate the space program, space exploration, space science, astronomy. So today we are here to gather and celebrate today's event. So we have one of the booming sector we have is that is a UAV and drone. So many of you might be knowing that we have heard about drone, UAV, but many of you are not aware what's the current opportunities, how to develop it. So today is a platform and where you can learn from the expert. We have Yadwinder Singh Khokkar. He has been expertise for more than 14-15 years in the field of aero-modelling. Not only that, he is also a certified pilot license holder, and throughout this journey he is also working different projects in last 14 years in the defense project, military projects, and other civil and commercial projects as well. And he is also connected with the different UAVs and drone companies, startup companies. He is also helping startup company. If you have any plan, you can contact us, and we can also help you. We can connect you through this Khokkar sir we have with us. We have another expert with us is our Eshwar Kumar Naidu. He is an aerospace engineer. Right now, he is specialized his domain on the drone engineering field, how to develop and build different types of drone, not only on the air and also the underwater drones. So we have both the super experts with us here today. So first I request our Khokkar sir to give a brief about this RC modeling to our audience, sir.
Thank you, ma'am.
Yeah.
And congratulations that your company is making big landmarks, and you are helping the students and universities in this field. And dear students, I am Yadwinder Singh Khokkar. Actually, I belong to Punjab district, Bathinda. And from my early childhood, I was very interested in, you can say, flying. The which type of flying? Myself flying. I was when I was 6 year old. I imagined, I dreamed about flying. This was my dream, and but I was not aware that flying without any machine or flying without any, you can say, aero model or aeroplane is impossible. So slowly, as I grew up and after my studies, my study was very different. My study was with geography, economics, and English honors, and I was not studying in engineering itself, but the basically my uh, inner incent take me to the hobby which was inner incent in my heart, and I slowly started the hobby of flying, and now after 15 or 16 years, you can say my childhood dream came into reality. That I have also taken a joyride on paragliding. My dream of flying also fulfilled. But after that, I am now busy in this RC hobby, RC flying hobby. And the RC flying hobby is the one of the, you can say, greatest hobby in the world. Although in India, it is in the very beginning part. We can say that only a little percentage of the people in India, they are enjoying this hobby. But in the world, if you see the other countries like England, America, Canada, Europe, there are so many flying fields and government helping the people to enjoy this hobby.
Right.
So in India, the RC flying hobby, or you can say UAV flying. UAV flying means unmanned aerial vehicle flying, is growing at a very large scale. So the basic thing is, first you have to learn the RC flying. The RC flying, I'm talking to you and also I'm showing you some RC models. You can see the model in white color lying on the table in front of me. This is the basic flying model. So when you learn this basic flying in this model, you can learn the behavior of air, how Bernoulli's principle work, how Newton third law, action and reaction, equal and opposite, how that work, how lithium polymer batteries, how magnetic induction work. So all these principles in the future, in the life which you are going to experience and which you are going to learn everything, they all start from a little flying hobby. That is RC flying hobby. So I am showing you some of my greatest models that I have made from thermocol, and all these are handmade aero models. This is the Cheetah Electric E1. I have named it Cheetah Electric E1, and I have shown the flying of this model at GNA University, Fagwada, and the students which were present at the time, they enjoyed its flying. And this is the C-130 Hercules. Actually, after learning the RC flying hobby, I have started making the scale models. You everybody know what are the scale models. Scale models are the actual replica of the actual bigger aeroplanes. So this is the replica of C-130 Hercules, and this is a replica of Antonov 225, the largest cargo plane in the world, which was destroyed during a war between Russia and Ukraine. The largest aeroplane, which was used to carry the spacecraft. Eshwar madam has discussed about the spacecraft and about the space week. The students who have joined the meeting, I think everybody, they are knowing that how the space shuttle, which was placed on the Antonov 225, and it was launched in the at a very great height, where the gravity also decreases at a high level. So this is my aero model's photo flying at Panjore Airport. So these are all our handmade aircrafts. And uh, today, we can only explain you in a brief manner. Actually, there is a detailed work for making an aero model, or considering its electronics and learning all about its parts and everything. You can say its a remote setup, its a battery setup. It takes a lot of time. Today we are making you a starting you a initializing you the startup, and you can see here are some parts. They are lying on my table. I am explaining you these parts one by one. Actually, uh, now in India, there is a great potential for RC flying and UAV flying, and there is a great potential for drone flying. because in defense sector, the government is using many types of bigger drones for providing the medicines to the army person and for providing the ammunition to the army person, the area where we are unable to reach, and the drones they carry the material by taking the GPS locations from our satellites. And these are the RC models. These are used for long range flying, just for mapping systems. Uh, you everybody, you must have listened about the aerial mapping. In India, now the project of aerial mapping is going at a very large scale. Aerial mapping is they make maps about your cities, your villages, and where the new roads are being constructed. They fly an aero model in VTOL setup. VTOL means vertical takeoff and landing setup, and they those planes they fly and they map that area, that a particular area, and they take the photographs. And after taking the photographs, they locate the areas, whether there are some trees or a river is there or some tower lines are there. And after that they make plans how to construct the road or how to construct any bigger project, you can say. So aerial mapping is also used in mining department. In we can say Rajasthan, where the marble mining is going on. You everybody know marble
Yeah.
mining. In marble mining sector, the mining there are deep, you can say, trenches from where the marbles is pulled out by many bigger cranes. And the custom officers and the tax officers, they take the you can say the investigation of that area with drones. They take photographs of that area, and after taking the photographs, they impose taxes on the miners, how many mining they have already done, and whether they are doing good or bad. Everything you can say. And in floods, you can see in Punjab, the last 2 months, it was very floody months. Everybody knows. And here in Punjab, the drones which we were using for agricultural spray, those are known as spray drones. And we used those drones for providing medicines and food materials to those people who were at the roof of their houses, because on every road and on every, you can say, way the going to the villages, there was water, and only water up to 8 to 10 feet. So drones were used at a large scale this time. So all these things, the things those which are flying in the air, we can take advantage of those things, and we can use the opportunity of those things. Even in agriculture sector nowadays, just last year I have taken a training from Delhi, from Gurgaon drone destination, about the spray, agriculture spray drone. And there are so many drones in Punjab, Haryana, Himachal, which are being used by farmers for the spray over different type of crops. In Punjab, we are using these drones for spray over a wheat crop, over rice crop, over sugarcane crop. In the sugarcane crop, it is very difficult to spray manually. So we use drones. And for other some crops which are very tall crops, we use drones, and they are very effective, and their spray mechanism is very effective. So due to these reasons, we have today planned a meeting just for journal, you can say, journal information to all of you about the UAVs, about the drones, how they work, how we can grab the opportunity. And I am going to explain you now about some parts of the aero model and some parts of the drone. And now I am giving some time to Madam Aishwarya to carry on the meeting. How to, I mean to say, from which side we have to begin the project.
Anything, sir, as per your convenience, sir.
Okay, thank you,
Yeah.
madam.
Yes.
And I am not showing my own photo because I am showing you aero models. Is it
Yes,
comfortable?
sir. It's fine. Fine, sir.
Okay, ma'am.
Yeah.
Dear viewers, please see, this is the basic aircraft. This is basic aircraft. The name of this aircraft is Sky Surfer. This is the basic glider category aircraft. There are so many categories of aircrafts. Some are gliders, some are aerobatics, some are fighters. The main difference, the among all the aircraft is about their wing design. Actually, all of us have read about the Bernoulli's principle. The Bernoulli's principle says that when in any medium we increase the speed of fluid or air, its pressure decreases. And when we decrease the speed of fluid or air in any medium, means a fluid medium or air medium, its pressure increases. So I have a cut cross section of a wing here in my hand. You can see this is the cross section. I am starting from the flying theory. I am explaining you, I am trying to explain you briefly. This is a cross section of a wing, and this is the leading edge of the wing.
Sir, sorry
If
to
we
interrupt in between. So, in your phone, is it possible to use like auto rotate? I think if you put an auto rotate, automatically
okay,
it will go in a landscape mode. Yes, sir.
okay, okay, okay,
Yes, sir.
okay,
So,
okay.
please. Yeah.
I am keeping my phone in one direction only. Okay.
Yeah.
Your dear students, see, this is the cross section view of a wing. Actually, this is the aircraft lying here. You can see in yellow and red color. This is the Cheetah 1E electric aeroplane, an aero model. So this is the cross section of this wing. I have make a cut of a small portion, and this is the cross section. Now I am trying to explain about the Bernoulli's principle, how it works. So this is the leading edge. This is the leading edge, and this is the trailing edge. So what happens when the main motor, when the main engine starts operating? This is the main engine of this plane. I am taking example of this plane only. This is the main brushless motor of this engine, this aeroplane. When it start moving in this direction, the propeller throws the air to the backward direction. What happens? Newton's third law. Newton's third law is action and reaction equal and opposite. So what happens? When the propeller rotates in this direction, it throws the air to the backward and it pushes the aero model to the forward direction. So when the aeroplane starts moving in the forward direction and it starts running at a great speed on the runway, so what happens? This portion, this is the leading edge. This divides the air into two parts, one upper part and one is lower part. So what happens? Now I am going to the again cross section, the cross section which I have already made. So, so this is the leading edge. When the aircraft starts moving forward, half of the air starts moving on the upper part and the half air starts moving on the lower part. What happens? If you measure this distance from this point to this point in the lower side, and if you measure the distance from the upper side, the distance as at the upper side is more than the distance at the lower side. So what happens? The air which flows over the wing, it starts moving at a high speed because its distance is more than the distance at the lower portion. So when the air starts moving at a high pressure on this side, here on this portion of the wing, a low pressure area gets created here. When you go to, you can search on the Google or YouTube, you can search how a flat bottom aerofoil works, or you can also search how Bernoulli's principle works. So what happens at this portion, a low pressure area created here and a high pressure area created on the lower portion. This, what happens, this pushes the wing on the upward direction, and this helps for an aeroplane or an aero model to take a lift and it becomes airborne. Now I'm showing you the wing from the side view. This is the main wing. And just I have explained you, this is the curved surface on the upper side and this is the flat surface on the lower side. This is the flat surface. So in this portion, a low pressure area creates, and this low pressure area helps the aero model to take a lift, and high pressure area from the lower portion. And when the total pressure of the air from the lower portion of the wing increases the total weight of our aero model, it starts flying in the air. Okay. And there are so many parts which are used in an aero model. Uh, before I explain you all the parts, I am going to explain about the parts of an aero model. Basically, in an aero model, there is one body, the long length body. You can see from top to bottom, a body which is also known as fuselage. And here this is the left wing, and this is the right wing, and this is the motor and a propeller which is fitted on the motor, and this is in the pusher configuration. Pusher configuration means this motor pushes our aero model in forward direction. Okay. And in these wings, here are some servos. These are servo motors. These servo motors which are used to control the controls, to move the control surfaces. Just like these are ailerons on the wings, these are ailerons. This is left aileron and this is the right aileron. And these tiny servos, this is 9-gram servo, we can say. This is 9-gram servos. These are classified according to their weight actually. And these two 9-gram servos, these are responsible for left or right turn. And you can see here, this is elevator servo. On the other side, this is rudder servo. Because when our aero model or aeroplane, both the principle flying for aero model or aeroplane, they are same. When an aero model starts flying in the air, these surfaces are used to make its left turn or right turn. I am just connecting these surfaces. I am connecting the battery actually to this plane, and I am going to explain you in more detail actually. And then after that, I will explain you all the parts separately, which are lying on my table. Wait a little. So now I have connected a lithium polymer battery here through this connector. This is XT60 connector, which is used to connect our battery and our ESC. And I have put on my remote, Fly Sky i6. So many students and so many hobbyists know about this remote. This is very cheap and best remote for starting this hobby. Now you can see this is the layout of my remote, and the left stick is for throttle. You can see throttle is moving, and right stick is for aileron movement. You can see ailerons are moving, and this is left turn, and this is right turn, and this is elevator up, elevator down. Now I am going to explain you little about these controls. Ailerons, they are used for left turn and for right turn. I have just explained you about the flying theory, how our aeroplane makes airborne. After that, how our air model or aeroplane turns left or right. It turns left or right with the help of these ailerons. Now you can see this aileron is in upward position, This aileron is in the downward position and my stick is to the extreme left. This is to the extreme left. The air moving on this aileron is diverted in the upward position, you can see.
Yes.
So the air which is diverted to the upward position, it places extra pressure here. It places extra pressure on this aileron, pressing it in the downward movement. And as the both ailerons, they are moving in opposite direction. When I'm giving left aileron going up and right aileron going in down direction. So the air from right wing, it trying to push the wing to the upward position. So the resultant vector is left turn. You can take your plane to the left turn. Similar, when we move our stick to the full right, what happens? Your left aileron going down and right aileron going up. And the all position that got reversed on now your aero model going to the right turn. So this is the left and right turn. And the surfaces which are moving up and down, they are all connected with servos. You can see these are servos, servo motors here. These are small motors and servo motors. These are geared motors actually. Geared motors, I am showing you some servos in my hand. These are 9-gram servos. This is new one lying in the box. Sorry, actually I am not having my helper today.
It's fine,
This
sir.
is the
It's
servo.
fine.
This is 9-gram servo. Here is a wire with this servo, and this wire actually is connected to the receiver. The receiver which is taking signal from this remote, and this remote sending signal to the receiver, and receiver sending signal to this servo. And servo is connected. You can see here, servo is connected by a wire. This is steel wire, and this is servo arm. It is connected to the control horn here in the aileron, and the aileron is moving left and right. So this is the basic left turn and right turn. Similar, this is the elevator turn. The elevator also known as horizontal stabilizer. The main function of elevator is when we push the sticks towards ourselves, just like this, what happens? Its elevator goes up. So when elevator goes up, what happens? The air moving from this direction gets diverted to upward direction. The resultant factor is air is making pressure on this elevator. So when air imposes pressure on this elevator, actually what happens? The total angle of your aircraft with the air gets increased. The angle of incidence. Some students which are studying aeronautical engineering, they
Yes.
must have read about the angle of incidence and the angle of attack. So angle of attack when it gets increased, and we increase the throttle. So our aero model starts moving in upward direction. Similar, when we push the elevator stick to the forward, what happens? Your elevator going down position. You can see elevator is going in the down position. What happens? When elevator moving in the down position, the air which were moving from here gets diverted in the downward direction. So it pushes the aero model's tail in the upward direction like this. So what happens when the tail gets pushed in the upward direction? The angle of attack of your aero model decreases with the air. So your model starts moving in the downward direction. So these are the basic controls, you can say, which are used in every actual aeroplane and in remotely piloted aircraft systems. The main ailerons for left movement, right movement, elevator for up movement, down movement, and this is the rudder movement. The movement one, which I am going to explain you. This is the rudder movement. The rudder stick. This stick is actually combined with throttle stick. If we are moving this stick on the upward direction, your motor starts moving. And in this stick, there is another movement, that is rudder movement. You can see. This is the rudder movement. and this is also known as vertical stabilizer. The function of vertical stabilizer is also to turn your airplane or an aero model or actual aeroplane, to turn your aero model in the left direction or in the right direction, keeping it in stable. Aileron also take left or right turn, but they make the turn by banking it, left banking or right banking. But the main function of rudder is to make the movement of your aircraft in leveled plane, you can say, in the level. So this is the movement of rudder movement. Okay. And these remotes which are using, this is Fly Sky. Basically, this is Fly Sky 6-channel remote. One channel is for aileron. This is aileron channel. 2-number channel for elevator. 3rd-number channel for your throttle. You can listen the sound of motor. Okay, and the 4-number channel is rudder. Basically, there are 4 channels which are basically used for flying of an aero model, and there are some switches lying here. You can see these are auxiliary channels, AUX channels, which are used for different purposes. Actually, these switches are mainly used in drone flying. When we fly our drones, we need to assign some flight modes in drones, just like altitude hold mode, return to launch mode, or you can say circle mode. So we use these switches. All the switches, they are used uh, when we programming our drones. So in an aero model, the use of these switches is very less, you can say. In some aero models, these switches are used for wheels. Actually, there are undercarriage wheels. When we put on the switch, the wheels go inside your aeroplane. Those are very you can say costly aeroplanes, which are made by many companies. The actual, you can say, the actual copy of the aeroplanes which are working in Word. So these switches, they are also used in aeroplanes and drones. And here in in on my table, there are some items lying. You can see this is bigger brushless motor. Actually, whenever I take workshop of the students, I always try to explain them about the brushed motor and the brushless motor, AC current, DC current. These are the basic things which are which we experience in our life. If you are engineer, if you are dealing with electronics, and if you are dealing with you can say engineering, all these things you will experience again and again in your life. So here is a motor I am showing you. Wait a second. Here is a motor which is a good example of brushed motor. I am showing you. Yes, lying here. Sorry. Please see. Actually, this is a motor, and this is motor. This is made in Canada. You can see made in Canada. This is a inverter of you can see 30 years before. This type of inverters were used to make a current, AC current, from a DC current. Here is a armature. The armature is moving like this. You can see. This is its armature. This is the moving part. So here the two slip rings, they are contacting with this commutator. So when we put voltage 24 volt from this side and negative from this side and positive from this side, this motor will start moving. This is an example of brushed motor. Brushed means carbon brush. The carbon brushes which are uh, making a friction with this commutator and providing the current to the commutator. You can see in detail, there are some parts. The commutator is divided in parts. You can see this is the commutator also divided in parts. So basically, I want to explain you about a brushed motor, that every time in a brushed motor, the two carbon brush, they always keeps on making a friction or keeps in touch with this commutator. So when the current flows through the commutator, it goes into the coil, which is the coil which is made into the you can say armature, and the second end of the coil is connected to the second portion. So that making the magnet in the motor, and motor starts moving. But in a brushless motor, this is a brushless motor. There is not a part which is making friction, not a part which is providing current to the commutator. Here we can see the three wires which are coming out of the motor, and this is the three-phase motor, you can say, the AC current, the alternating current motor, and the three-phase, which is three alternating phase which are going to the motor. The three-phase, they are provided by the ESC. This is the ESC, the electronic speed controller. The electronic speed controller, it takes current from the battery, the red wire positive, the black wire negative, and this is the sense wire. This is the sense wire which connected to our receiver. And this ESC provides current to the brushless motor in the form of three phase. And these three phases are alternating current phase. Alternating current, uh, you everybody, I think you are knowing about the alternating current, the sine wave current, sine wave going upward and sine wave going downward, and all the three wires, these are gets connected with the three wires of this motor, and motor starts moving when we put on a battery here, and motor starts moving. And I'm showing you this motor by opening the outrunner cup. Hold a second. So this is the stator. This is the 12 pole stator, and we provide current in the form of three phase. These are the three phase, 1, 2, and 3. And the current provided to these three phase is provided by the ESC through these three wires we connect here. And this is the outrunner. The outrunner, which is fitted by so many, not so many, these are fitted with 13 magnets. These are 13 neodymium magnets. When we put on a battery here, the ESC starts sending signal to your motor, and all these poles, they are winded with a copper wire. You can see this is a copper wire on every pole. So if this pole is winded in clockwise direction, then this is in anti-clockwise, this is clockwise, this anti-clockwise. I mean to say, all they are 12 poles, and 6 poles are clockwise winded, and six poles are counterclockwise winded by the copper wire. So suppose in this pole, when we put on a current, this pole gets north pole. The magnet in this pole gets north, and in this pole it gets south, north, south, north, south, north, south. So what happens? These poles starts pushing the motors out on the cup in direction like this. Because everybody knows that like poles, what happens? Like poles repel each other, and unlike poles attract each other. So the concept of like poles and unlike poles works perfectly in this brushless motor, and there is not a single part which is creating friction, not a carbon brush, you can say, like this motor. Here is not, we are not having any carbon brush here, we are not having any direct current connection, and all what we are doing, we are providing current in the three phase. So not going to the more details for this motor, or these are so many type of motors, means in size, you can say. This is the smaller version, this is the small motor, this is also a brushless motor, you can say, with three wires. This is the bigger motor, this is another one motor, this is also a brushless motor. And these motors, two motors, they are capable to carry a 18-inch propeller, very great thrust. With 18-inch propeller fitted on this motor, it is very easy to fly a plane just in this size. This is 9 kg Aero model, and we have fitted a motor, this one. over here. You can see the size of motor. This is 50, 60, 380 kV. I am also going to explain you about the kV. What is the kV? What is the 50 and what is the 60? So the power of these motors is very big power, you can say. But in when we look over these motors, they are very tiny, looking small motors, but they are having very great power. These are the uh, in these motors, the poles are more than 12 poles. These are 30 poles motor. The function is same. These are also brushless motor. The motor is Sunny Sky. You can see the company name Sunny Sky motor. This is 4112. kV value is 400 kV. So these are different motors fitted in these aero model. Now I am going to explain you some little bit about the kV value of the motor and size of the motor. Here in this motor I have shown you. I am going to again showing you this motor. There are two values, that is 50, 60. Actually, what is this? The cup size is 50 mm, this one, and the cup length is 60 mm. These four digits, numeric digits, they signifies about the size of the motor. 50 means the diameter of the cup, and 60 means the diameter, the length of the cup, this one. And what is kV? This is 380 kV motor. The kV means when you multiply the kV value with the provided voltage, if you are operating this motor, that just I have shown you, if you are operating this motor on 11 voltage, you what you have to do, just multiply 11 voltage with 380 kV. The result, which result will occur, that is the maximum RPM of the motor at the full throttle. I think you everybody have understood. I'm explaining you again. This is a smaller motor in my hand. The size of the motor is 82212. 60. 60 means 6 turns. There are 6 turns on a stator. This is the stator. The stator is winded up by 6 turns of copper wire. So this motor is 2200 kV motor, and the capacity of this motor is maximum up to 14 volt. So multiply by 14 with 2200 kV. The result which you are getting, that is the maximum RPM. RPM means round per minute of this motor at full throttle. So this motor is used in our sky surfer glider. You can see here. We have used this type of motor in this sky surfer glider. So this was all about the motors, brushless motors and brushed motors. Now I am going to explain you about something, the batteries. We are using so many batteries in our life, our mobile battery, our car battery, our jeep battery, our tractor battery. Okay. Previously we were using only uh, before 20 years we were using only lead acetate battery, PB, जिसको हम PB बोलते हैं, PB lead battery. PB in chemistry, the PB signifies the lead, that those were the lead acetate batteries. Now we have shifted to the lithium polymer batteries. Lithium is also a, you can say, metal, and the scientists and the engineers, they have uh, made a such type of, you can say, the derivatives from this lithium polymers. They have made the polymers. They have mixed some type of chemicals and some type of, you can say, metals with lithium, and they have made a battery which is capable to store a current in it. So this is the battery which I am holding in my hand. This is a lithium polymer battery. We also call it LiPo battery, LiPo, LiPo battery. So this battery is in, the capacity of this battery is 2200 mAh. The 2200 mAh, actually what is its size? A battery with the same 14 voltage may be in 2200 mAh, or it may be in 10,000 mAh also. So the mAh is the size of the battery. I am explaining you in the another way. Suppose you are having two buckets. One bucket is carrying 20 liter of water and it is placed at a height of, you can say, 20 feet. And you are having another bucket which is carrying 100 liter of water and is also that is placed at 20 feet of height. So there is a common, there is tap in the both the buckets. The size of the tap is same in the both the buckets. And we have opened the taps. And which bucket will empty first? The bucket with the smaller volume of water. And the bucket with the larger volume of water will last for a longer time. Same is the reason in here batteries. A battery with 14.8 voltage may be a battery of 2200 mAh, it may be a 1800 mAh, or it may be also a you can say 25,000 mAh. Here are some batteries lying over here in my lab. These are very bigger batteries. I am showing you. This is the Garuda Aerospace battery, which I am using for my agriculture spray drone. And you can see and imagine the size of this battery. This is the 25,000 mAh and the size of battery 6 cell battery. It is 6 cell battery. And one thing more I am going to add you. A lithium polymer cell, when gets fully charged, the value of the cell is 4.20 when it gets full charge. And when we are using battery and when we have used the battery up to a you can say some extent, the voltage of the cell drops and it comes to 3.8 or 3.7. The 3.7 value is discharged value, and we are not going to discharge more than that value. And if we are going to discharge the battery again below 3.7, the battery will be gets damaged. So this is 4 cell battery, 2200 mAh. This is 25,000 mAh. This is 6 cell battery. So
Sir,
some
is it okay to ask question over here, sir?
G. Yes, please.
Sir, ये जो battery है, this battery, right? So you are
G.
showing Garuda Aerospace battery and there is another battery, right? So
Yes.
what's the difference in terms of endurance
Difference in
and
terms of
weight?
endurance.
या मतलब कितना टाइम स्पैन चलेगा मतलब फुल चार्ज हो गया एंड हाउ लॉन्ग इट इज़ गोइंग टू लास्ट.
Actually, madam, it depends on the uses of battery
ओके.
and in which aero model you are using that battery. Actually, this is very heavy weight battery. This is up to 2 kg weight battery. This is 2
ओके.
kg weight battery. And you can see it's in my hand, you can see the size.
यस.
And this battery is not capable for this aero model. We
या.
cannot place it in this aero model. You can see the size and
यस.
aero model's battery size.
राइट.
So these are different batteries. They are used for different aeroplanes, different drones.
या.
This battery, this is 2200 mAh. This battery is for this model. You can see.
या.
So the question which you are asking, the endurance of the battery,
या.
it depends upon the size of your aero model, the design of your aero model. But on an average, I can say that this battery, that this 2200 mAh 14 voltage battery, this battery is capable to fly this sky surfer for half an hour.
ओके.
Yes, we can fly it for a half an hour with this
alright.
battery. Okay, and the four cells you are seeing, one, two, three, four. This is 4 cell battery. Multiply 4 cell with 4.20. That will the maximum value of the battery at full charge.
Right.
Okay. And this is the discharge plug. This is the discharge plug which is connected to the ESC, and this is the charging plug and the balance port.
Right.
This is the balance port. Balance port is used to balance the battery when we charge the battery. Actually, we need to balance the cells individually. So this is the charger which is used to balance and charge the battery. I am also showing the charger. This is charger.
Yes.
This is the simple charger, and these are the buttons which are used to change the configuration in this display here. Because this charger is capable to charge the battery from 2 cell to 6 cell. You can see on the display. So here we put the balance plugs in this side, or you can see this is the bigger battery with 6 cell plug.
Yeah.
This charger also capable to charge this battery. So this is all about the battery and the charger, and we are also using lithium ion cells. Lithium ion cell. Uh, so many students and so many people, they are having laptops in their hands, and those laptops, they are equipped with lithium ion cells. I'm also showing you lithium ion cell. Lithium ion cell, they are hard body cell. You can see this is a lithium ion cell in my hand. This is lithium ion cell, and this is Molicell. Molicell, a good company making lithium ion cells, and the capacity of this cell is 21770. The cell model is 2177, and this is, I think, 5000 mAh cell. This is P50, means 5000 mAh capacity, and the voltage of this cell is 4.20 at full charge. Okay, and these cells are good. The cycle of these cells can exceed 1,000 cycles of charge and discharge. I want to explain to the students about the charging and discharging cycles. When we charge a battery for one time and making a discharge of this battery for the second time, this is called one cycle. And these batteries, they are capable to provide us up to 1,000 cycles. Means on an average, if we are using a battery, we can use it for 3 years. Okay, we can use it for 3 years. These batteries, they are capable for having a cycle of up to 1,000 times. And these cells, they are more than these batteries. These cells are capable to charge and discharge for more than, we can say, 1,000 times. Okay, and these are lithium ion cells. We need to solder here. This is the positive terminal, and this is the negative terminal. And make sure while you are making a battery from these cells, these are very dangerous. Sometimes these cells blast if we make any short circuit, or we are heating with soldering iron up to a great heat here, and these cells can blast. So please take care about these cells.
Okay.
Okay, and
Sir, I have
some
one more relevant question, if you allow. So
okay,
some students are doing some project. I think Ishwar sir can also answer for it.
okay,
Both of you can give your point of view. So
okay,
mostly, being an aerospace and engineers, they do different projects, right? So
okay,
maybe for competitions, for other things. So so first of all, the main challenge for them is a payload, right? So to design and fabricate the fuselage and all, right? Now it
okay,
comes to the endurance part. For an example, if they given a task or an challenge that they have to endure for 24 hours. For an example,
okay,
it is an they're making some drone for surveillance kind of thing. So,
okay.
what are the challenges you think the students will face, and what are the tips would like to give to them? Yeah.
Okay, actually, for a long time endurance, the main thing which you have to keep in mind is about the weight of your aircraft.
Hmm.
The weight of your aircraft should be very less. You can made carbon fiber body, or you can use balsa wood. Actually, the weight, if you are increasing the weight of your aircraft, the battery weight, the aircraft is taking your battery weight actually.
Yeah.
I mean to say, save the weight of aircraft, that weight will be occupied by your battery.
Yes.
If your aircraft is, for an example, your aircraft is 2 kg weight, and you are
Okay.
putting a battery of 600 gram or 500 gram in this aircraft, and if you have decreased the weight of your aircraft with 200 grams, you can increase the weight of your battery. Simple.
Yes.
By increasing
So
the weight
another
of your
challenge.
battery.
Now, for an example, you have this sky surfer, this flight. This is a glider, right? Powered
Okay,
glider, and
okay,
this Garuda Aerospace a battery. It will not fit there,
okay.
and the
Yes,
endurance of Garuda Aerospace battery is much higher as compared with 220. So imagine with
okay,
that flight, I want to make it endure for 24 hours. So you said this
okay.
2200 mAh battery can last for 30 minutes, right? But my
Yes,
challenge is that I have to endure for 24 hours. So now if I
okay,
want to use Garuda Aerospace flight, it will also a challenge for increasing the weight and fitting issues and everything. So how,
okay.
yeah,
Yes. The main thing is the how much weight your aircraft can carry.
yes,
The thing is, the aircraft lying in front of me on this table, this aircraft is capable to carry maximum payload, you can say up to 300 or 400 grams.
yes,
And we can increase this battery if the weight of this battery, for example, is you can say 300 grams.
yeah,
We can use the battery instead of this battery, we can use 600-gram battery.
yes, yes,
We can increase the flying time, but for this aircraft, we cannot use this battery. If you want to use this battery, then you have to go to bigger version of aircraft, this like this, or bigger gliders, you can say.
yes,
We have to increase the size of our aircraft and design of our aircraft.
right, right.
This is the challenge.
And I would like to hear a few words from Ishwar sir. So if you
Ji,
enlighten us
please.
Yeah,
with some,
yeah, ma'am. To add, am I audible?
yeah, yeah, you're audible.
Yeah, first of all, based on your query, you need an endurance of 24 hours, right? So that 24 to get the hours of endurance, as Khokkar sir is telling, weight is the main factor. So at the end, weight only tells us like how much endurance you are going to get. The lesser the weight, the more the battery capacity you can incorporate in that, right? At the end, uh, how much time you are going to fly depends on the motor what you are using, at what efficiency you are going to use that. The more the efficient propulsion system you are going to use, the more the endurance obviously you are going to get. Currently with the I mean, as per my knowledge, as per my experience, currently with the electric propulsion it would be difficult to achieve 24 hours of endurance. So for
hmm.
that, industrial standard, we will incorporate a hybrid propulsion system like a petrol engine plus a battery.
Okay. So I have
Yeah, there
Yes.
are limitations from the battery tech currently. Soon, I
Or
hope
we
that this will change.
or
Yeah.
or we can also go for a you can say solar power plane
okay.
on these wings. Now in market, the flexible solar plates, you can say the plates solar system which we are using in our houses, those are very heavy in weight. But now in market, the flexible solar, you can say solar paper type is also available, which we can fix over here on the wings,
Okay.
on this wing,
Yeah.
and that solar panel that will provide power to our battery,
Yes.
and we can increase the endurance during the daytime. We can increase the power of this battery. Our project is going on. Our project is under you can say R&D, research and
Yes.
development. Our one project is going, and when that project gets finalized, I will also explain that to all the students.
Right, that will be great, sir. And yes,
Yes.
there was some question that why we can't, dominate during daytime, why we can dominate during solar panel. But again, there are certain, I think, constraints if we talk about solar panel. Again, we have to be restricted only on the daytime. Nighttime, it
Okay.
can recharge the battery. That means 12 hours solar panel, 12 hours the
Yes.
battery. And I think Ishwar sir has highlighted one thing about petrol plus
Hybrid
hybrid.
engine.
A
Yeah,
hybrid propulsion.
yes. So
Hmm.
petrol also will need a tank. Again, the weight will increase. So do you think it's really going to be effective for such kind of mechanism or any other alternative solution? Or maybe you, if you're doing some project right now, you can give some thing about it.
Okay, ma'am. First of all, petrol, why I'm telling hybrid propulsion is at the end specific energy density. Specific energy density is nothing but how much per what's the propulsion weight will be there, right?
Yeah.
Power energy weight, right?
Yeah.
So how much weight you are carrying, how much energy? Let's suppose battery is having, as sir showed one battery of
Yes.
25,000 mAh, right? It is having
Yes.
2 kgs of weight. In that 2 kgs of weight, how much energy it is going to carry is the point at the end. Compare it to the electric propulsion, like completely depending on battery. In petrol engines or hybrid propulsion, if you go with that, specific energy density will be higher. No matter your weight is increasing, if you don't have weight constraint, like there will be certain constraints sometimes. You need to complete, like sometimes you might need to complete our drone category in smaller category, like up to 25 kgs or 2 kgs, nano category. In these kind of things, one more option we could incorporate. As you are saying, it is for surveillance based, right? So we
Yeah.
can incorporate tether based drones also. Tether based drone means a continuous power supply will be given to the drone using a tether. This
Okay.
is
Mhm.
this is possible with multi-rotor drones.
Okay.
And for
Mhm.
surveillance, multi-rotor drones would be the best option to give using like incorporating the theater technology. Multi-rotor drones would be the best possible way to get the more endurance and the more work done.
My
Okay.
Or else we need to.
Yeah, I think
Yes, sir.
Hanji,
yes, sir.
Continue,
Khokkar
please.
sir.
Hanji,
Yes, sir.
sorry, I'm interrupting you. My Tiger drones, my three models, they are working with the defense forces.
Yes.
I have designed three models in Tiger drones. They are getting ground power from this some ground power station from our, you can say, the house plug,
Yes.
220 volt AC. They are operating on 220 volt AC current. And sir, you are saying you are saying exactly true. The Tiger drone, we can fly it for a long time. We can fly it for 3 hours, 4 hours, or up to 10 hours. We can say,
Yeah.
Yeah,
because the ground power, that is unlimited power. And
unlimited we can supply. Yes, sir.
yes, and there is nothing bigger system in this. We only, what we need is to convert your AC current into DC current. Nothing. We need a conversion of AC current to DC current. That's all. Your drone flies on DC current actually. And the hybrid engine, which you are asking about, a hybrid engine in India, in I have seen in some videos, the drones, the spray drones, they are using the hybrid engines. Actually, the hybrid engine, this is fitted with a generator with this engine. You can say the flywheel of the engine, which makes a rotational movement. That flywheel is equipped with induction coils which produce a magneto effect, and it produces current, and that current goes directly to the, you can say, drone system, where battery is connected in a parallel connection. And whenever engine gets stopped, the battery provides a backup for 4 to 5 minutes, and we can fly that drone for a long time by putting a petrol, because petrol is having a great calorific value.
Yes.
Well, one liter of petrol can provide you enormous energy.
Yes.
So the question, I'm coming to the question again, which madam has put question for the long time flying. We can
Yes.
use petrol engines also for the long time flying,
Okay.
but the issue is there are some delicate areas, there are some security areas which are which the areas in which those areas defense forces are using drones and aero models. But if we are using engine powered drone there, there is a lot of sound in that engine.
Yes, IR
Yeah.
signature will be there.
Yeah, the lot of
Yes.
sound that is easily detectable from a great distance that something is flying over there. So due to that reason, we are only we can say we can only fly electric plane or electric drone over there.
Right.
Yes.
Okay.
Yes, sir.
I think
Totally agree with you. It depends on application, right? Where we are going to
yes.
apply and
Yes, I
what
think
application we are serving for. Yeah.
yeah, I think it
Yes.
is. I think it's one of the very, very important point to take away that drone design is all up to the purpose that how you're designing and where you
Yes.
are portraying, whether it's a surveillance for military or defense, and we can see here one of the drone. Sir, would you like to give some briefing about this UAV drone? Is there anything special on this? We can see
Yes,
something different.
yes, I am
Yeah.
showing you about this is quadcopter setup. Actually, drones are in, you can say, tricopter, quadcopter, hexacopter, octacopter setup. The tricopter, they are having only three propellers.
Okay.
The quadcopters, they are having four propellers. You are saying this is a quadcopter.
Right.
And hexacopter, they are using six motors, six propellers.
Yes.
And octacopter, sorry, they are using eight motors.
Oh, sir,
So
one
the
question coming in my mind. Sorry to interrupt. So I have
yes,
seen recently. I think last time when we met, you were flying. I think hexacopter, if I'm not
yes,
wrong. So,
yes.
like, is there any difference in weight or that and this one? Can you just distinct between these two?
Actually, the by increasing the number of motors or and number of propellers, we are going to increase its thrust basically.
Right.
Its weight carrying capacity. We are increasing its weight carrying capacity by increasing the number of motors.
Thrust. Yeah. Where?
So just like this is in this drone is equipped with 4110 motors, and this is a propeller of 15 inches.
Okay.
And this drone is in quadcopter setup. Okay, the maximum payload for this drone is not more than 500 to 600 grams.
Okay.
Okay, and the drone which we are using for agriculture spray, actually, today I was not prepared for this, and in the next meeting I will also show a spray drone.
Okay. Sure,
So
sir.
in that spray drone we are using these bigger motors. These are
Okay.
motors just this size,
Okay.
X8 motors, and with a propeller of 24-inch.
Okay.
And the total number of motors is six motors in that drone, and it is capable to carry 14 liters of water with pesticide mixed in that water. Roughly, you can say 14 to 15 kg of dead weight.
Okay.
Okay,
Yeah.
the thing I want to explain you that if you are increasing the size of the motor and increasing the diameter of the propeller and increasing the number of motors, we are simply increasing the load carrying capacity of the drone.
Yes.
Okay,
And
now
yes, sir. What
Hanji,
is inside? Yeah, we are very much
yes,
eager
good.
to see what's inside.
I am explaining you.
Yeah.
Basically, uh, in an aero model, this is an aero model, and the aero models lying behind. You can see so many aero models.
Yes, sir.
This is also aero model. In an aero model, the total flying of an aero model is totally depends on the skill of the pilot.
Right, sir.
There is nothing automatic fitted in these aero models, and these aero models can fly only up to your line of sight.
Yes.
Line of sight means your eyes, your eyes seeing up to what extent or up to what you can say range.
Right, sir.
If you're seeing up to a distance of 500 meters, you can only fly these aero models up to a that distance, up to which distance you are capable to see properly.
Right, sir.
But what happens in a drone? In a drone, we use a flight controller. This is a flight controller. This is NASA M-Lite flight controller, and this is GPS. So when we fly these drones, just when we take off the drone from the ground, it marks its position as a home position from the point from where it take off, from where it takes off. Okay. So when your drone is going at a distance from your starting point, the logbook, the processor in this controller and your GPS starts moving a logbook. The logbook, what logbook? You about your direction, your north, your south, your east, and your west. It starts making a log in its brain
Yes.
that from your home position up to which position, up in which direction you are going. So if your drone, you have sent your drone up to a great distance, you can say you have sent your drone up to a kilometer of your from your home position, and
Yes.
now you are not seeing the drone, and the drone is not visible, or you are not seeing the orientation of the drone, which side is on the forward and which side on the backward, and you are just seeing it like a something little dot you can say in the sky. So just what we do, we simply flip the switch to the RTL mode, that is return to launch, and this drone will return to your starting position automatically through its logbook, which it has created in its mind.
Yes.
Okay, so
Yeah.
this is the main difference between a drone and in an aero model.
Yeah. And I
Okay,
have one small question to Ishwar sir. Sir, you are working in a company, right? As an UAV
UAV
engineer.
design and fabrication engineer. Yeah.
Yeah, fabricating, right? So, what are the challenges you faced while designing? Do you, in your company, do they make the same this kind of model, or what are the challenges do you face? Yeah.
Basically, I work like based on the client requirements, we do develop the drones.
Okay.
Okay, it's not like already available one we take and modify. From scratch, we develop the drone. Whether it could be its calculations, how much trust, what motor need to be selected. As Sir showed you, how to select the motor based on KVs and what capacity of battery need to be selected. And for ESC
Right.
also ratings will be there. These and all need to be considered. So we do this. We do this. We put all this together into the softwares at the end, and we need to while designing also we need to consider a lot of weight criteria. We need to consider, we should not give dead weights from the structural side. We need to consider the material, what kind of material you are going, the lightest weight material we need to use with the great strength. And stability, in the stability factor you need to consider, take care of CG also at the time of designing. And to get the more little more endurance, you need to consider about the aerodynamical aspect also if it comes to a multi-rotor drones. So like this lot of it's like a multiple factors you need to consider being a design engineer or while designing a drone. It's not like a single task, just you make a CAD model and make it fly. Because
Right.
at the end it is going to experience the real world like real environment it is going to experience. To sustain that, there are a lot of physics is needed, mathematics and physics is needed, whether
Okay.
it could be CG estimations or battery calculations, endurance estimations, how much payload need to be carried, and these are like how many life cycles the drone should give, how much
Okay.
time it should sustain, what kind of gust wind means suddenly sometimes while flying like from other directions the wind will be there. That and all we need to predict. We need to sustain at what kind of wind conditions, how much speed we need to maintain. These all we need to feed. As Sir showed, one flight controller, NESA, DJ NESA flight controller Sir showed, right? So in that, the flight controller, it's a hardware. Again, in that software will be there, which again considers all mathematics and physics together. That software
Yes.
also we need to consider, like how the in what condition how the drone should act. It's like we
Yes.
are making it more smart using these flight controllers. Those things also, even the flight controller placement in the drone also affects how the drone will be controlled.
Yes, I
It's
think we
like
can
multiple factors
see
are there.
Sir is having a hub of his different flights and different models. And the same, I think other companies that they have engineers where Ishwar, like the designers are sitting there. We have some question for both of you, asked by some like our audience and participants. I request you guys to answer for it. How can we get an RC body parts? We can get it in 3D printing, which is very cost effective. Not at all cost effective. So, what are the alternative do you suggest for it? Yeah.
Hanji ma'am, you have asked about the 3D printer. I have
Yes.
focused my camera on this 3D printer. You can see
Yeah.
this is 3D printer, and here is a roll of PLA wire, or you can say PETG wire, which enters from this stepper motor, and this printer prints the design over here on the printing bed. We can make very cheap aero models, or you can say the designs
Hmm.
of aeroplanes, the designs of rockets, the design of boats, the design of cars. You can say everything is possible on 3D printers. We can use. I am also using 3D printer whenever I make bigger aeroplanes. Just I have made a copy of Boeing 747 lying over there. You can see.
Yeah, we can see it, sir.
Yeah, Boeing. I designed a prototype copy of Boeing over here in my printer, and that was only 10 to 11 inches in size. And I calculated all the you can say the all the measurements from that dummy type of model, and made another actual model. So we can use a 3D printer for making aero models, for making drone legs even. The legs which are used in drones,
Yeah.
the you can say मैं आपको अभी दिखा रहा हूँ ये this is the prototype of a simple drone. These legs these are printed by a 3D printer. You can see.
Okay.
These are printed by a 3D printer. There are nowadays there are so many printers. Not only a PLA printer, there are even carbon fiber printers available in the market. We
Yes.
can directly print a carbon fiber. Okay,
Yeah.
and the another thing the which I am using, I have worked for 15 years on thermocol. You have seen in my lab.
Yes, sir.
I am making my aero models from thermocol, high density thermocol,
Yes.
and I am also making from Depron sheet.
Hmm.
That is very cost effective and very cheap, you can say. I am showing you a little part. This is a cross section of a wing which I have printed on
Okay.
my 3D printer. You can see
Yes.
this part. This is printed on my 3D printer, and this is the part of a 6 feet glider.
Okay.
Yes, this is the wing part actually. This part. This is the wing part.
Right.
Okay, we can use 3D printer. We can use cheap materials which are easily available in our Indian market. You
Okay.
can say yes.
Right.
Please.
So I think you're suggesting that if they have a 3D printer and if they print it with their own configuration, it is going to be
Yes.
very reasonable, not that
Yes.
costly to get it from the market. Right?
Yes. There
And
are so
a
many.
point,
Yeah. I.
Please.
yes, sir, please
Please.
continue, sir. Please
Please,
continue,
sir.
sir.
Yes, I mean to say there are so many, you can say, software websites which are providing you the software and the STL files which are used to print in these printers. We use STL files.
Yes, sir.
There are so many companies which are providing you STL files at a very, you can say, cheaper rate,
So
cheaper
in
price.
fact, there are some free STL files are also available in internet.
Yes.
Yeah.
Download that STL file and convert that STL file into slicing software and directly put the memory card, your pen drive into your
Yes.
printer and you
Print.
can print.
Yes.
Yes. Yes, please.
Yeah, Ishwar sir.
Yeah, ma'am. I would like to add one point. If you like, the cheapest option is, as sir said, thermocols and cardboards and wood. These are the cheapest option. But I would suggest 3D printer is also a cost-effective way. Why? Because whatever you can imagine, you can get it manufactured using 3D printing.
Right.
There will
Yes.
be no, there won't be any restriction. Like structure need to be like this only. Sir had shown one arm of the drone, right?
Yeah.
Considering that you have seen it's a very critical structure to manufacture with the traditional practices like using a wood or any other carb like thermocol and all. But with 3D printer, it's just like you design whatever you are imagining, you just feed it to the printer, it
So
will get
true.
it manufactured to you. It's
So
very
true.
Exactly.
cost effective
Exactly.
way compared to rest of the manufacturing technologies. It's like very cost effective and like time conservative.
Right.
I am showing you another part. I have just found my another part. This
It's a
is
base of a
the
fuselage.
front part of glider. You can see.
Yeah. Right.
This is the front part of glider, and here is the motor compartment here, and this is the battery compartment here,
Hmm.
and this part is printed on this printer. Here is 3D printer,
Yeah.
and it prints like this in this direction. It prints it like this,
Yes.
and this is very easy and very interesting to operate.
Yes.
Very interesting system. This is a very interesting system, you can say.
Right. So we have one
Yes.
more similar question. That, sir, very great knowledge you have. All you have shared today. How much does it cost? 3D printing machine that you are using. Is it okay to share? Means you can tell, sir.
Yes, yes,
Otherwise,
please. This
yeah.
is not very costly. If we go 5 years or 6 years back, it was up to you can say 36,000 to 38,000 rupees cost.
Mm-hmm.
And now this is Ender 5 Pro machine. Ender 5 Pro. This is the Ender 5.
Okay.
Okay,
So I
I
think you
think
can note down that. Yeah.
the cost of this machine is not more than not more than 30,000.
Okay. Right.
Yes.
And ma'am, I would like to add a point.
Yes.
Nowadays, 3D printers has become very cheap. So even at the starting price of the 3D printer starts at 13,000.
Hmm.
There you go.
13,000,
Okay,
1 3.
that's great.
That is
Yeah, it's
another.
like yeah, it's an FD based printer. So basic price is 13. For the beginners, it is very suitable. And when
Very good.
other printing technologies like resin based printing, like we'll use a liquid resin to print the parts. Here, the solid filament is being used, right? As the sir
Yeah.
showed in that printer. So other type
Yes.
of printers are there, which are like different types of 3D printing technologies are there, like powder
Mhm.
based, resin based. So resin
Yeah.
based printers also, the good thing is nowadays coming for around 15 16,000. It's like to
Okay.
Okay.
get smooth surface finishing and all, you will get it for very cheaper price nowadays.
It's very
And
interesting.
It's not,
that is very with good finishing. You can say that is the finishing of
yes,
that surface print is very excellent.
Yeah, and I think that is one of the costliest among all the current 3D printers that in current
Yes.
scenario.
yes, exactly. Two, 3 years
These are
back,
the
if you
roles.
consider,
These are the roles which are used in this printer. This is PET G.
Yeah, I think you can note down, and if you are thinking to plan to buy
Uh,
your own 3D printer, so I request audience and the participants, you can make a
yeah.
note of it. Yeah,
Yes.
I think I have one more similar question in our chat box. There was a question. I want to pursue my career as a drone engineer and UAV engineer. Is it really noteworthy? Companies are hiring this field. Kindly guide for this.
Which
I didn't
question?
get your question.
Yes, please.
Kindly
Yes.
repeat the question. No?
Okay.
Repeat the question, ma'am. Hanji.
Okay. Uh, he or she wanted to pursue her or his career as a drone engineer, drone pilot.
Hmm.
So they're asking that is it really worthy taking this as a career profile? Is there any worthy companies hiring this field?
Yes, bilkul. There are so many companies in India. They are seeking for engineers as engineers to assemble drones and pilots to operate the drones. You can uh, you can contact the Garuda Aerospace, or you can contact the drone destination at Gurgaon. If anybody near from Delhi,
Hmm.
there are so many companies in South, in Bangalore. There are so many companies. They are in a
Yes.
urgent need for so many engineers and so many flyers.
Yes, and Garuda Aerospace itself having I think different branches. I think for
Yes.
drone, Hyderabad, Chennai, Bangalore, they became a hub for it. And I think we would like to hear some few words about from Ishwar sir. Yeah,
Yeah, ma'am. Coming to the drone industry, there are more than 700 companies in India. There are more than
700.
700 drone companies. Yes, yes. Official and unofficially, there are more than 700 companies
This
which
is
are looking
another
for,
interesting thing that I'm listening. 700. So it's a
yeah,
huge.
Huge
it's
number.
very huge because it's drone industry started. It's in baby stage right now. We can't see the rapid results in right now, like within 1 year, 2 year. It's like we need to be very patient.
Okay.
You need to be very patient towards this drone. It's like in the long run, if you see, it's
Hmm.
the field in every application, drones will be there. According to my consideration, in every field, in every application, drones will serve. And moreover, I told you 700, 800 companies are there nearly. All are looking for from freshers to experienced people in every domain. It's not like only aerospace or aeronautical engineer has to join.
Yes.
Drone needs mechanical engineers, electrical engineers, uh, PCB designers, embedded engineers, software engineers, AI engineers, ML engineers. Multiple domains are incorporated into these drones. It's like, and if you are interested in teaching, remote pilot training officer you can become, and
Instructor
if you are
and
interested in
instructor.
piloting, yeah, instructor, and if
Hmm.
you are interested in flying the drones you can become a pilot. There is a lot of scope in terms of opportunities. The thing is, initially you need to start something, you need to gain little experience. For that, I believe the RC modeling is the best option, is the best
Yes.
option to start with your drone career.
Okay.
Yeah,
Even
opportunities are more. There is no need to think of that, is it worthy or it is. Yes, absolutely it is worthy. So I am currently working as a UAV design and fabrication engineer. From past 2 years I am working. So I have seen this every day, day by day, technology is changing like anything. It's
Okay.
like very rapidly it is changing. So you shouldn't be bothered about will it be worthy or not. Yes, it will be worthy.
Okay, that's nicely stated. I think this is a very interesting fact that we came to know today, and I hope the audience have also learned about it. That this career is really worthy. So I would like to get some insight how we can, what are the challenges or how we can get an drone pilot. Suppose a person is working or citizen of India, so he or she got the drone pilot. After that, whether they can go abroad and be the same, or they have to get a different license. So I
Yes,
think, yeah.
yes, they need to get a different license actually.
Hmm.
Uh, there are some common things which are same all over the world, the flying theory and the
Hmm.
all about the electronics, but there are some rules which are different rules in India and different rules over in the foreign countries.
Right, sir.
My son Jajar Singh, your student, and he has got a drone pilot license in Canada,
Okay.
and
Very happy.
there was yes, and over there in Canada, he got a training from the training company for 7 days, and after that, he gave a test and a flying test to those company members, and he got the license.
Great. So I think
Uh,
it's different. I think you can go and look into this Drone India Rules and Regulations 2021. So you can find all the facilities. All you can first visit a DigiSky website
yes.
where you can get to know more about this drone rules and regulations in India.
Yes, that is compulsory, ma'am. That is compulsory. I want to add more to your words
Yes, sir.
that some students don't know about the DGCA rules. What are the DGCA rules? Directorate
Right.
General of Civil Aviation, the
Yes.
department which gives license to the pilots and which give permissions to the drone operators and aero modelers. And there are some conditions which they have imposed over us. The main condition is not flying near an airport, not flying near a army area, not flying near a government building, and there are zones they have already marked over the digital sky map. You can go to the Google map,
Yes.
you can search the digital sky map, and
Yes.
there are red zones, yellow zones, and green zones.
Yes.
We are not supposed to fly in the red zone, and if we want to fly in the yellow zone, we need permission from the ATC controller or that certified that area, particular area in which the yellow zone is imposed.
Right,
and
sir.
in the green zone, the maximum height which we can fly is 400 feet only.
Yes.
Okay, and flying in the visual line of sight, that is called VLOS, visual line of sight. As a beginner without a license, we cannot go the
Sorry.
beyond line of sight, that is BVLOS, beyond visual line of sight. As a beginner, we cannot go beyond visual line of sight. So these are
Right.
the things which every flyer should take into consideration. Please.
Right, sir. Ishwar, sir, you would like to add on anything?
Yeah, I would like to add the great power comes with the great technology comes with great power. So the power should not be misused. So for that we need to have rules and regulations. And coming to the license you get in India is regulated by DGCA, which is the authority controlling all flying related uh, rules and regulations in India. The same won't be applicable if you go to Canada or US. But according to their authorities, you need to again take the different license. But at the end, skill remains the same. Flying is flying everywhere.
Yes.
Yes. And Ishwar, sir, I would like to ask one final question of today's session. That you are an aerospace engineer and you are deviated your field towards drone engineering. So,
Yeah.
what is more interesting? Like, you decided that you wanted to be a drone engineer. Like, how you started your career? Like, from aerospace, being an aerospace engineer and drone fabrication, you are right now. So, can you tell your journey behind this? Yeah.
Yeah. Okay. So after the graduation, actually in drone again aerospace comes into picture. it's not only related to aerospace, but aerospace is also included in drone. Okay, as a after graduation, I started my career as an intern in at a robotics company in Chandigarh. Okay, there it's a startup actually. So there I saw how a startups works. Actually, I'm always interested in doing something new. It's not like I don't like to do the one already done. You need to modify or you need to additionally add the points to that or additionally do changes and all. I like to innovate. So that's where I came to know that future is going to be robotics and drones. Drones are also nothing but robotics, but aerial robotics. Even in that aspect, I started my career with the another company in Bangalore. Again, it's a startup, very base level startup. Very base means it haven't even registered the time I joined. After I joined, they got registered, but the project was very interesting. It's an amphibian drone. Amphibian drone is nothing but a drone, a dual mode drone, a drone which can fly and can submerge in water too. There I understood working on innovative projects how it's like at the end what all we need is after work is satisfaction. Is that what we are doing is what we should love, or else we should do what we love, right? So I am doing the what we call work which is I love every time because I love to innovate. I don't want to be an normal engineer. I want to be an innovative engineer. So I chose
Something,
this field and
something extra,
something,
something extra.
yes, something extra need to be there because it's very competitive world nowadays. If you are not defining your path separately, if you want to join with everyone, you are not going to survive in long run. Maybe you may survive today, but tomorrow it would be difficult for you. I don't want that, so I chose different path. For that, I hope drone industry is the best possible way based on my education and my skill set, what I learned during my education and all. So currently also I am working with one startup only. Again here I'm working on multi rotors for nano category surveillance and human assisting drones like it assists army people and one micro category drone. These two drone projects currently I'm working on. Again it's a startup based in Bangalore.
So good to know about it and the journey. Khokkar sir, like I would like to hear, like how was your journey from the farming to make an world record? You have made the world record, right? Creating the world's first small prototype that Antonov you
Yes.
have made. So how you got the idea to develop that and make a world record? Please share an insights to our audience.
Actually, in the starting, I just explained previously that my dream was to fly like a bird. But at that time, I was only, I think, 5 to 6 year old, and I don't know how I can fly like a bird. So what I did, I climbed on the roof of my house, and I started moving like arms like this, and I was near to jump from the roof of my house. That my mother came from the behind and slapped on my back. बेवकूफ क्या कर रहा है मरेगा. These were the words. This type of feeling I was carrying from my childhood. And after that, I was indulged in my study and schooling, and after that, my college. Basically, I want to become an engineer, but the circumstances were not in that time. Circumstances were not in the favor of becoming an engineer. I got graduation in geography, economics, and English honors, and after that, I got a diploma and a postgraduate diploma in computer applications. And in 2007, I got a chance to go to UK, United Kingdom, England. There was a marriage of our some relatives there, and I, with my wife, we we go there. And from Delhi, I took my flight in Air India, and I by chance my seat was on the wing of that aeroplane, and the flight time was during the daytime. And when the aeroplane got take off, and I started watching the wing of the aeroplane, how the ailerons were moving. At that time, I was not aware what were the ailerons, what are the flaps, and what are the spoilers. And I, in the 8 to 9 hours of flight, I keeps on watching the wing and the wing flux. You know the wing flux, wing moving like this.
Yes.
That is the wing flux. At that time, I got worried that it will break. Okay, these were the feelings in my heart and in my brain. And from England, I got two smaller aero models, just this size, and one was helicopter and another was a biplane, smaller biplane. And one of them was broken in my luggage, and one aeroplane I got over here and started its flying and learned about its flying. At that time, I was not aware about the ailerons, elevator, what is going inside, how is the flying theory working. So the thing which helped me is All India Aero Modeling Institute at Delhi, AMAI, ऑल इंडिया एरो मॉडलिंग जो है ना, एक बना हुआ है, ऑल इंडिया लेवल के ऊपर एक एसोसिएशन बना हुआ है।
Hmm.
तो उन्होंने एक इंस्टीट्यूशन किसी टाइम खोला था, तो वो लोगों को मैगजीन सेंड कर देते थे। दे सेंड मैगजीन्स, मंथली मैगजीन्स। इन दोज मैगजीन्स the flying theory, the motor setup, everything they explained about that. So then after that, I read some books about the flying theory. I got a book from my uncle, and the uncle who is retired from army. The name of that book is Flight Without Formula.
Yes.
I read all the book thoroughly, and I got so many points from that book and from the Google, from YouTube,
Hmm.
the flying theory, the CG, how CG works, what is the role of CG, how Bernoulli principle work, and after that, step by step, I was moving upward, and I've spent so many money from importing the models from Hong Kong, from America, from China. Those were all thermocol models, or you can say EPO models.
Hmm.
Those were very costly models. By paying so many custom duties at Delhi, I purchased those models. They were even some models, they go to lakhs of rupees.
Okay.
So after that, I got frustrated. This hobby, I cannot carry this hobby at a such high cost. So I slowly, by seeing videos, by seeing so many builders, they are making aero models in Europe and in America on the YouTube, on Google. I adopted thermocol. I adopted thermocol, my basic ingredient to make an aeroplane.
Right.
So I started working before 15 years on thermocol. Okay, and the first aero model which I gave to the students from a university from Chandigarh, and that model was in very small size, and that model worked very well. And after that, I stopped purchasing models from online, and I have started making my own aero model. And slowly, I got a record, and three models in India Book of Record, one model in Asia Book of Record, the largest handmade working aero model made up of thermocol. That is my
Yes.
record in Asia Book of Record. And the same model, I have entitled that, I have sent a request for world record. The model Antonov 225 with a wingspan of 12 feet and a total flying weight of 23 kg. And when you see the photo of this
Yeah.
model, I am again showing you the photo. This aero model flying at Panjore airfield. You can see.
Yes, sir. It looks
Ah,
exactly like it's really a realistic picture. Looks
yes,
like an, yeah.
yes. And this is my journey, ma'am. And so many times I am now serving many universities. Actually, I provide the practical knowledge, not going to the theory only. I prefer practical knowledge.
Yes, sir.
How practically Newton's law work, how practically Bernoulli principle work, how practically induction work,
It shows, sir.
how
And when I personally visited your house, I can see there is a vertical windmill is also there at your house.
yes, yes, yes,
So it shows that sometimes your dedication matter, not only the degree. Yes, degree
yes,
can serve you in a better place, but
yes,
if you don't have dedication, we have two experts with us here today. One is
yes.
Khokkar sir, is no words for him, and another
Thank
experts
you.
we
Thank
have
you.
Eshwar Kumar. He is also growing and booming. How he has dived his career from aerospace to an drone industry. That's a live example in front of us here with us today. I hope our audience is really enjoying this session. And so I think we can wind up the session here because it's going too long. So, any few
Okay.
words to our audience, sir, you can say in small words, sir. Any suggestions to our student or our audience first goes with Khokkar sir.
Yes. Actually, there is a phrase. The phrase is work is worship. Okay. When you are going to, I mean to say, you are going to make a thing, you are going to going through a competition. I mean to say, any competition, IS competition, IPS
Yes.
competition, or you are making a hobby competition. You consider that hobby just like your worship God. When you worship that hobby or your passion just like God, while sleeping you remember God, while you are awake you remember God, you breathe you remember God. When you start remembering your hobby, your passion just like remembering God, then nobody will stop you to go at the higher you can see higher heights. This is my the main keywords to the students.
Thank you, sir. And any keywords from Ishwar sir?
Yeah, ma'am. Your dedication and consistency decides your destination. And if you are very interested in drone industry, it's not a rocket science. It's very easy to achieve. But initial starting point for this is RC modeling. Any domain, irrespective of your degree or your age, anything, anyone can start with the RC hobby flying, in which
Right.
you will understand the basics of a drone. You will understand all the parts of a drone. Then again, in a long scale, it's take you to for the career options. You will explore multiple career options like I am exploring now.
Yeah.
It's like
And
that.
I want to add a little point
Yes,
more
sir.
that
Sure, sir.
previously
Sure, sir.
I forget that point. If anybody want to learn a remote control flying, you
Yeah.
can use these RC simulators.
Yeah.
These are the softwares which we load on our computer system, our laptop or your tabletop. And these simulators they provide a wide range of aero models and drones to learn flying. And the same remote which we use to fly our aero models and our drones, the same remote is used to operate your RC simulator. Here is a point.
Hmm.
This is simulator point over here, and we can
Yeah,
use
it's
this
visible.
remote for to learn flying through your computer. Yes.
Okay, so I think this is a complete package of this UAV engineers drone, the opportunities and how what are the basic components that are used. I hope all our audience have really enjoyed this session, and special thanks to today's expert, that Khokkar sir and Ishwar
Thank you.
Kumar,
Thank you.
for being with us and a very short notice that you have accepted our invitation. We are really really glad for devoting your dedication and time for this session, and also for our wonderful audience there. Thank
Yeah,
you, sir.
I would like to thank
Thank you.
Aishwarya Dharaman
Thank you.
and
Thank
Academy
you.
Innova World team for
Thank
Thank
giving
you.
you,
me this
everyone.
opportunity.
Thank you,
Thank
sir.
you. Thank you.
Thank you,
Jai
sir.
Hind.
Jai Hind,
Jai
sir.
Hind.
Jai Hind.
Jai Hind.
We can wind up the session here, sir. Thank you so much.
Thank
Okay.
you.
Thank you, sir.
Thank you so
Thank you,
much, ma'am.
everyone. Thank you. So, audience, I hope all of you have a really, really enjoyed this session, and please do not forget to give the feedback link, fill up the feedback link. That's very, very important to get your certificate, which is available in our chat box. And I hope you have really enjoyed this session. Please give the honest feedback and how you felt about this real time session. Especially this session, as you know, it's all about the UAV engineers and drone, the robotics, the upcoming this aerial robotics, as you can see. So please, I hope you have really really enjoyed, and once again wish you an exciting space week. So it is a 3D program, so tomorrow also we have an exciting audience with us and expert with us we have with us tomorrow. And so from Boeing, and one more experts entrepreneur we have here, a very popular entrepreneur. So stay tuned with us, and don't forget to subscribe, like and share with the needy fellows about these insights. So stay tuned with us, stay tuned with Innova World. Good night. Jai Hind. stay tuned with us. Stay tuned with Innova World. Good night. Jai Hind.